It looks like an A, but it's like 30.
So
like,
wait,
you're
did
so
you say Greek or Korean?
Greek.
Huh?
What if we Korean?
Okay.
But it's just like.
So chapter 11, we have been talking about hypothesis testing, and we are going to kind of extend this to look at 2 different samples at a time. So a lot of this, we are going to do an example or 2 today by hand, but it's going to a lot of times fall on, we'll probably do most of them on the calculator. So I'll show you by hand, I'll show you the classical and the p-value just like I've done with all the others, but the majority of the time we will rely on our calculator. We are looking at what's called matched pairs data. So all of our requirements are very similar. It has to be simple random sampling. We have to have normally distributed, no outliers. Since we're going to be talking about our means, we're looking at n has to be bigger than 30 independent samples. The only new requirement here, to use this strategy, you have to have matched pairs. So we have to have 2 sets of data that are related. We'll still do our null and alternative hypothesis. The difference here is we're still talking about the mean, the mu. So is that the t or the z? T. Mean is the t-test, which is the one that we did almost exclusively on the calculator because remember the table for the t distribution didn't have enough values for us to always get a great t value. You'll see we have a subscript d on all of these. Because we're looking at 2 sets of data, what we're going to do is compare the difference between the 2. So we'll be subtracting the 2 to essentially make a 3rd set, and we'll be analyzing everything from that 3rd set, the difference between the 2. Okay, we'll still have our alpha, which is, we know the seriousness of making the type 1 error. Then we have our approaches. So the classical approach, you do your test statistic. So our t is, now this looks a little bit different. If you look at your formula sheets,
did you seriously do your stats without a formula sheet?
Mm-hmm.
Did you pass?
I'm so proud of you.
Thank you.
Oh, she's creating stuff. She's teaching us.
The old t, we were comparing a sample with a population. This time, instead of doing our x bar minus our population mean, we are just going to take the 2 sets of data, find the mean of their differences, and then divide that. This is all, of course, on your formula sheet, so not a big deal there. Then we would have to, classical approach, you have to use your degrees of freedom to look it up and then decide if you reject or not, just like we've done before. With the p-value approach, you're still finding your t and then using your p-value. A lot of times we are going to use our calculator to find our p-value. So the approaches are very similar to what we've done in the past. I want to take a look at a set of data, and we're going to kind of run through all of the options for how to do this. So the following data, I think I left you a few blank slides after this one, represents the cost of a one-night stay in a Hampton Inn hotels and La Quinta Inn hotels for a random sample of 10 cities. Test the claim that the Hampton Inns are priced differently at the alpha equals 0.05 level of significance. Okay, so our null hypothesis would be like saying they are priced the same. So the null will be that the mean of the differences is 0. The alternative, what am I trying to decide?
They're different.
If they're different. So that would be not equal to 0. So we do put that little subscript D on there just to kind of help us to note that we're talking about the differences between these. This is matched pairs data because you are looking at 2 points from each city. You know, in each city I take one hotel.
Why would it just be 0?
If they're the same price, when you
Okay,
subtract them you get
got
0.
it.
Okay. So step 1 we are going to have to use our calculator unless you really want to go through and subtract all these and find the difference by hand, which I don't want to. So, you're going stat edit, and I want you to put the Hampton Inn in L1 and the La Quinta in L2. So here's our L1, here's our L2. Everybody enter your data. Each of these in L1 and L2. I want you to go to L3 and then use your up arrow so you're actually on the title, the L3. And at the bottom it should say L3 equals. We want our L3 to equal L1 minus L2. So if you hit second and the number 1 button, you see there's an L1 above that. And then you do your minus, and then second, the number 2 button is an L2. So you have L1 minus L2, hit enter, and it creates our list 3 for us, the difference between all those. So we don't have to bother subtracting it. It'll do it for you. Now, if you entered a new point into L1 and L2, it's like if we had another data pair set, you would have to go recalculate, redo the L3. It won't keep adding them on, if that makes sense. So if you add on points, you have to go do the L3 thing again to make it get the rest of them. Okay, so does everyone have the L1, L2, L3? Okay. So now, let's talk about how we can do this. If we, let's just go stick with the calculator for a minute. So if you go to stat test, what would this one be called? If we're
2 sample t-test?
We're doing a t-test. We are actually, though, we're going to do it as a 1 sample because we've already calculated that L3, which is the difference. That's the only piece we're using. So we're just going to do number 2, the t-test. Okay, do we want it based on data or stats? Data. Okay, your mu sub 0, what do we want the difference to be? 0, so set that as 0. Okay, here's where you have to pay attention. Your list, which L3. So if you hit second number 3, it'll bring up L3 for you. Okay, we're going to keep the frequency at 1, and we are testing not equal to. So calculate. So it tells us that T is 5.2. No, hold on. So our T value is the 5.27. Is that what you guys got? What is our P?
5.13.
Except look at the end.
Oh, 0, 0, 0.
Okay, so you have to watch that scientific notation. So if we are just sticking with the p-value approach like we're doing right here, how do we know if we reject or not?
Is it less than or greater than 0.5? Is that it? Or 0.5?
Right, if your p-value, I should really put this label up here. If your p-value is less than your alpha, then you reject. So we're really doing it the p-value approach, which is the one we stick with most of the time. So if we look at this, my p is smaller than my alpha, so that means you reject the null.
So we don't have to look at the chart.
Not for the p-value approach. This is the way I will have you do it most of the time. I wanted to just walk through the classical with you so you have an idea of what it is, but this is not one that I will ask you to do, just like we haven't done the classical approach on the others. It's just more for your information. For this one, you have to have your degrees of freedom. How many degrees of freedom would we have? 9. Okay, and then we need our T alpha. So my alpha is 0.05. Because this is two-sided, you would have to divide that by 2. So now you have to look at your T table. Okay, so my alpha is 0.025, 9 degrees of freedom. Since it's two-sided, we have to put the plus and minus on this. Okay, plus and minus 2.262. So what those are saying, in the classical approach, those are your, essentially like your critical values. So this is positive 2.262. This is the negative. If your T value is in that shaded region, you reject. If it's not, you fail to reject. We found our T value up here to be 5.2716. So that would tell me we reject her. No. So that's your classical. I didn't really talk about how to do the T value by hand. We just got it off our calculator. Are you interested? We'll go through it. Okay. So define the T value by hand. I gave you the formula. And I said your T sub 0 is the mean of the difference divided by S over the square root of it. Now the reason we did it on our calculator is we didn't find the mean by hand, did we? But we could. Or somewhat by hand. Let's use our calculator since everything's entered in here already. Go to Stat, Calculate, One Variable Statistics. Which list do you think I want if I'm trying to find the mean of the difference? L3. So you need to change your list to L3. And then calculate. And it tells you your X bar is 51.4. Your S is 30.8336 divided by, what was our N? It tells you, square root of 10. So if we use that formula that I gave you at the beginning, do we get the same T value? 12716. Our calculator told us the T value was the same thing. The decimals are slightly different as we go on due to rounding error, but you could very easily calculate that T by hand. Now there's really no point because we already entered all the data in our calculator, so if we took the time to do that, we might as well let it tell us where everything is. But if I asked you to find it by hand, you could. So, tell me the sentence I would write. What's my final conclusion?
We reject the data because there is sufficient evidence to suggest that they are different.
Yeah. There's sufficient evidence to conclude that hotels are priced differently.
The French is probably sketchy. $49 for a night.
Someone stayed at
In Tennessee?
yeah, wasn't the one with the love bar?
Yeah.
No, we have barbed wire, razor wire.
Razor wires.
And then Will set off the fire alarm with toast.
Yeah, you burnt toast and set off a fire alarm.
Not my
Alright, so if I wanted, we've done the 1 minus alpha percent, 95%, 99% confidence intervals. We've done those many, many times by now. So to do that, you have to take the mean of the difference plus and minus your T alpha over 2 times the standard deviation of your difference over the square root of n. Okay, this is very similar if you look at your formula sheets to the confidence intervals that we've done before. If you look under chapter 9, the confidence intervals for your T is x bar plus or minus. The only difference is that one had x bar and regular S. This is using D for the difference, so it's the mean and standard deviation of the difference. Otherwise, confidence interval is the same as what you were doing on your last test. So, remember you have to watch your degrees of freedom when you calculate your T alpha. And otherwise, it's pretty much the same thing. So let's do one. Let's find a 99 or a 90% confidence interval for the mean difference in the prices. So if we go back to those one variable statistics that we calculated. So on my one variable stats, we know that what it says is x bar, that's our difference, so that was 51.4. The standard deviation of our difference was 30.8336. Our n is 10. The other piece that we're going to need in this is our T. How many degrees of freedom do we have? Okay, so our T alpha over 2. We're talking about 90%. So alpha is 0.1 divided by 2. So that's our T, 0.05. So if you go to your T table, 9 degrees of freedom, 0.05. What's our T statistic?
1.8.
Okay, so then we could do the formula. So it's your mean of the difference plus and minus your T alpha over 2 times your standard deviation of the difference divided by square root of n.
Okay, I have a question. Like, when we were in elementary school or whatever, like, why did teachers tell us, like, multiplication is like an X, but then, like, we just have to change it when we get older? Why not just, like, start with, like, the little dot?
Because kids' handwriting is very sloppy, and a little dot is hard for them.
I guess that makes sense, but, like, still, like, it...
Well, Frank still uses the X, so then
I
I
mean-
use the X, and then I get confused just thinking that's a variable. And
No.
sometimes she'll use the dot. It's just But
Okay, do you guys get this confidence interval? Now, is my confidence interval perfect? Why? What's off? What did I round?
1.8336, and then the 51.4.
Yeah. Well, yeah, this number especially, my standard deviation, if you keep a few more decimal places there, you might be more exact. Okay. Now, this is how to do it by hand. Your calculator can do confidence intervals for you. Especially when we already have all of our data entered. It's not a big stretch to do that. So if you go to Stat, Test, go down. We want an interval, but we don't want a Z interval, we want T. So it's number 8, a T interval. Our input is our data. What list should we be on? L3. Frequency is 1. What confidence level did I want?
90.
So confidence level 0.9 and calculate. And it gives us
Yeah. We were pretty close.
yeah, why we said ours is slightly different because we rounded our standard deviation, but you can do it either way. Unless I specifically say do it by hand, do it on calculator. Okay. Questions there? I would like for you guys to do one on your own. We're just going to do a problem out of the book, I think. Okay. I want you to flip to page 544. And we are going to look at number 9. We are not going to do the A, B, and C necessarily. We're going to do, let's just do 9C. So take a second, I would like you to try that on your own. The null hypothesis should be the same.
Mean equals 0.
The mean of the difference. So please use this proper notation, mu sub d equals 0. And then the alternative, what are we wanting to see?
Greater than.
Not, oh wait, no,
Oh,
I
the
don't
other
know.
one, less than.
Less than. Not the same.
I don't know, I'm just waiting for you guys to agree on something.
Greater
Greater
than.
than.
What are we trying to find?
No.
Is the
If
data
it's-
higher?
No, it's greater
No,
than.
if the SUV sustains less damage.
Do the
Okay.
data suggest repair costs for cars higher?
So it's going to depend on how you set up your L3. If your L3 is L1 minus L2, so if you make your third list SUV minus car, and you want the car to be higher, what would you do? Okay, so there are different options. So this is the one thing, a lot of times in the problem I may tell you how to set up your difference. Typically, unless I say otherwise, I just do the first minus the last. But if you make your L1 the SUV, and you make your L2 the car, and we want to know if the car is higher, then you have two options. If your L3 is the SUV minus the car, then your null would have to be, or sorry, your alternative would have to be what? Trying to decide if the car is more. It would have to be less than 0.
Alligator eats the big one.
Because if the car is more, when you subtract those, you would get a negative. Now, if you did your L3 to be the car minus the SUV, then your alternative would be the mean is greater than. So, how you do your list impacts how you have to set up your null. That's why you have to know what you're setting up, and you need to let me know in some way, shape, or form. That's why I did this problem, so you would realize how we have to think about it. Like I said, on a lot of the problems, I may tell you, this one does not specify. So I did the first one. I usually just do L1 minus L2, unless it tells me otherwise. So I'm going to say the mean of my difference is less than 0, because I'm going to set up my list this way. What I ask of you is that if you are putting these in your calculator, tell me what your L3 is. Is it L1 minus L2 or L2 minus L1? That will allow me to check if your alternative hypothesis is correct. Does that make sense to everybody? So, you entered those in L1 and L2. For the L3, you're going to go L1 minus L2, the way we have it set up. So then if we go to our stat test, we want t-test. Input is data, your mu sub 0 is, list is, we said we wanted the less than, and calculate. I get a t-value of negative 2.6855, and my p is 0.0181. So then the question on part C, does the data suggest the repair cost for the car is higher? Use an alpha equals 0.05. So is that greater than or less than alpha? That is less than, so what does that mean? We reject the null. The data suggests. The car repair costs are higher. Go ahead and do the confidence interval real quick for this one. If I ask for it, I want to make sure you remember how. Do it on your calculator. Where do you go to find the confidence interval on your calculator? Stat, test, which one is it? Number 8, t-interval. So we're basing it on data. Let's do a 94% confidence interval. So we would be 94% confident that the mean difference in SUV minus car is between negative 2,079 and negative 154.8. Would that make us accept or reject our null? Reject, because our null is saying the mean is 0. Is 0 in that interval? No. So this confidence interval is another way that you can decide whether you accept or reject. Okay, questions there? This is the assignment. Due to the fact that these really require the calculator to do them efficiently without wasting a lot of time, I'm going to give you class time tomorrow to do this assignment. So you actually don't have any homework that you have to do tonight. You will have class time to work on this tomorrow.